Good morning, student. I am Ashraf, Imam. I welcome to you YouTube channel Jesus Mary Academy. I am faculty of geography of Jesus Mary Academy. Today I will teach standard ninth, third chapter, rotation and revolution. It means the motion of the earth I will teach. Student, please listen to me carefully. Before that, I am going to tell you something about the movement of the earth. Earth, while spinning on its axis, also circle around the sun in an elliptical orbit. While the movement of the earth on its axis is called rotation, the movement around the sun on its axis or orbit is called revolution. Both rotation and revolution of the earth occur simultaneously. These movements influence many natural phenomena like day and night, season, ocean, currents, winds in the earth. Now, student, I am going to tell you about rotation and revolution. Every day we observe the sun rising in the east and with it start the day. At noon it is at the highest position in the sky and thereafter it start declining to set in the west. In the evening, this daily movement of the sun's path across the sky makes the imagine that the earth is stationary and the sun is moving around the earth, but in fact the position is just the reverse. Actually, the sun is stationary and the earth moves. In fact, the earth's climate is affected by air temperature, wind, ocean currents, precipitation, changing length of day and night, annual cycle of seasons, etc., which are highly controlled by the earth's daily as well as annual movement. These movements are called rotation and revolution respectively. Rotation. The earth rotates on its axis and completes one rotation in 23 hours, 56 minutes and 4 seconds, approximately 24 hours. Are you understanding, student? The earth spins from west to east on this axis. An axis is defined as a vertical imaginary line that runs through the center of the earth from north pole to south pole. Rotation is the spinning of the earth around its own axis from west to east. If we keep a distant star, which is a fixed object, as a point of reference, we find that the earth takes 23 hours, 56 minutes and 4 seconds, my dear student, to complete one rotation to make one day, which is known as a sidereal day. Sidus in Latin means a star. Now, student, while considering the overhead midday sun at noon as a point of reference for a given meridian, the day is 24 hours long. This day is known as mean solar day. The difference of nearly 4 minutes between sidereal day and the mean solar day is caused due to another motion of the earth around the sun called revolution, which covers one of orbit of revolution each day. The axis of the earth is an imaginary line passing through the center of the earth on which it rotates, my dear student. The earth takes 24 hours to complete one rotation on its own axis. The two poles, namely the north pole and south pole, my dear student, make two ends or limit of the axis. The axis is not vertical, but it makes an angle of 23 degree with the vertical or 66 degree with the plane of earth orbit, that is known as tilt of the earth axis. The tilt of the earth axis is also known as the inclination of the earth axis. The tilt or inclination of axis always remains pointed in the same direction towards the pole star during revolution. Now student, I am going to tell about effects of the earth's rotation. The first, velocity of the earth rotation. For completing one rotation, earth takes 24 hours. This makes that the earth complete one spin on its axis at a high speed. As circumference of the earth at the equator is approximately 40,067 km, the speed of the earth approximately is 1669 km per hour. That is speed we can divide by speed is equal to distance by time. We can divide distance by time, then we get the per hour speed of the earth. The per hour speed of the earth is a 1669.45 km per hour. Per hour the earth. So the velocity of the earth is 1669 km per hour to the east. However, the speed of the earth rotation is not the same at all places as in an oblate spheroid. The latitude decreases in their length as they move away from the equator. As a result of the velocity of the earth, its maximum at the equator and reduces as it moves toward the pole. As the pole have negligible length of latitude, the velocity of the movement of the earth at the pole is almost zero. Next, now I am going to tell about the circle of illumination. The earth rotates from west to east. As it rotates, only half of the sphere, which faces the sun, experiences day. The other half of the sphere that remains away from the sun experiences night. This experiment we can do with the help of a bulb and torch. A dark room, it may we can lit our torch, and one side of the torch light we give to fall one side of the ball. The side of the wall which get the light of the sun, it tells the day. Another side which doesn't get the light of the torch, it is known as the night. The imaginary lines demarcating day and night is known as a circular illumination. As the earth rotates from west to east, every part of it faces the sun at least once a day. The eastern part experiences a new day earlier than the western parts. The earth rotates very fast. A point located at the equator has to complete a journey of nearly 40,000 km length of the equatorial circumference in 24 hours. So the speed would be 40,000 divided by 24, that we can talk about 1,666.66 km rounded. We can talk about 1670 km per hour. Now, celestial bodies seems to move from east to west. The rotation of the earth at high velocity makes the sun and the moon seem to be rising from the east and setting to the west. This is because of the same phenomena that we observe while moving in fast speeding train. When the trees and the other objects outside the window seem to be moving from the opposite directions or direction. The celestial bodies are also in motion, but they appear to be in a fixed position because of the distance from the earth. The tides occur twice a day. Their westward progress is due to the rotation of the earth from west to east. Day and night experience alternately in 24 hours is due to the rotation of the earth. Apparent movement of the sun and the moon and the star, other planets from east to west across the sky is due to the rotation of the earth from west to east. That is why the sun appears to rise in the east and sets in the west every day. Now student, I am going to tell about Coriolis effect. The rotation of the earth also prompts the winds and ocean current to deflect in different directions. The velocity of the earth is not uniform at all places. It is maximum at the equator and negligible at the pole. This variation in velocity causes winds and ocean currents to deflect in opposite directions in the northern and southern hemisphere. In northern hemisphere, the wind and ocean current are deflected to the right. In the southern hemisphere, the winds and ocean current are deflected to the west. This deflection of wind and ocean current are referred to as Coriolis effect. Now student, I am going to tell to you occurrence of the tides. The rotation of the earth also causes tides in the ocean 2 times a day due to rotation. And tide occur twice a day and their westward progress is due to the rotation of the earth from west to east. Earth shape, geoid or oblate spheroid is caused by rotation. The earth is bulged at the equator and slightly flattened at the two poles. Rotation causes centrifugal force that causes slight bulge at the equator. Shape of the earth. The oblate spherical shape of the earth, where it bulges at the center and it is flattened at the poles, is due to the effect of the rotation of the earth on its axis, my dear student. The diameter of the earth at the equator is 43 or 42 km more than the diameter at the poles. The difference between the diameter of the pole and diameter of the equator. Occurrence of day and night. The most evident effect of the earth rotation is the phenomena of day and night. Circle of illumination is the imaginary line that separate the earth into two halves, my dear student. One half experiencing daylight, another half night. Because the earth rotates from west to east, only half of it that faces the sun and that experiences daylight, the other half that faces away from the sun remains in the darkness. Now student, I am going to tell to you inclination of the earth axis. The earth is tilted toward one side, always facing the poles, the pole star. As it revolves around the sun, the path of the earth or the orbit on which it circles around the sun is elliptical in shape. This orbit of the earth lies on the sun elliptical plane or the plane of the orbit of the sun. Next student, I am going to teach to you about the it means perihelion. The orbit is not exactly circular, so the sun is not centrally placed within it. As a result, the distance between the earth and the sun changes during the revolution also. When the earth revolves around the sun, the position of the axis at any point in time always faces the point in the sky, that is the pole star. This phenomena called parallelism of axis. With the help of this figure, in the above figure, the North Pole, Earth, orbital plane, Sun. In the above figure, we can observe that due to the tilt of the axis, the North Pole is inclined toward the Sun, while the South Pole is away from the Sun. The tilt of the Earth axis greatly influences the length of day and nights and affect the season in areas that are further away from the equator. With the help of a diagram, when the North Pole is inclined toward the Sun, we can observe. On the Arctic Circle, the latitude distance AB is completely within the rays of the Sun, and this place does not experience darkness during this time. On the Tropic of Cancer, the distance Cx is smaller than xd, indicating the night is shorter than the day. On the equator, distance EO equal to OF, indicating it means. Now I'm going to teach about change of season. While the earth rotates around its axis, the revolves around the sun within the tilt away facing the sun. The north pole moves away from the sun while the south pole inclines toward the sun. This prompt change in season. When the north pole tilts toward the sun, the northern hemisphere experiences summer and the southern hemisphere experiences winter. Alternatively, Alternatively, when the south pole tilts toward the sun, the southern hemisphere experiences summer and the northern hemisphere experiences winter season. The climate on the equator remains the same throughout the year. If the earth axis had not been perpendicular to the elliptic plane instead of being inclined, then all the places on the earth would have had equal days and equal nights with no climate change throughout the year. Remaining part of this chapter, it means the revolution, I will teach in my next class. Thank you, student. Have a nice day. Please listen this video attentively and make a short note in your notebook.